Welcome to today's webinar. My name is Jamie. I am the Marketing Campaign Manager at DLT Solutions. We are excited to introduce you to Red Hat OpenShift. Prior to getting started, I'd like to go over a few housekeeping items. Please mute your phones at all times. If you have any questions during the presentation, please place these questions in the chat box on the right and we will address them during our Q&A. Please do not put us on hold if you are not on mute, as we will hear the background music. This webinar will be recorded for future on-demand viewing within DLT Marketplace portals. I'd like to introduce our speakers today, Aaron and Jared at Cornerstone, who will be discussing today's topic, Red Hat OpenShift.
Thank you, Jamie. Did you have anything else?
Nope, it's all you.
All right, awesome. Well, we appreciate you guys joining us today. Not sure where you're calling from, but we're around the Raleigh, North Carolina area. Here's our just a quick snapshot of us. We have Jared, who will kind of be leading more into the overview and technical dive of OpenShift. He comes with a lot of experience and expertise around Kubernetes and OpenShift, specifically more on the commercial side. And my name is Aaron. I'm more on the business development kind of side of Cornerstone, and been with the company for about 1.5 years now. So definitely enjoying the experience and the time here. But just a housekeeping on our end as well. Feel free to keep this interactive. I know we've got a smaller group, so we're definitely happy to. You can, if you can see at the bottom, we've got the hand, so feel free to tap that, and we can call on you if you have a question. Feel free to turn on your camera and get interactive and grab some coffee. I know it's been a rainy day where Jared and I are, so I definitely have mine sitting here beside me. So, and a little bit about us. I won't kind of bore you with some of the overview of our company, but just a little bit, background about us. So we are an IT solutions provider, better known. We do a little bit more. We're not just your typical kind of hardware and VoIP kind of managed service provider, but we do a little bit more specifically lately on the DevSecOps side. And particularly, we've been more of a service arm and provider for DLT, as well as Red Hat Consulting, two of our bigger partners. So do a lot of the Kubernetes and OpenShift, deployments and engagements when it comes to those conversations, as well as having more experience and expertise when it comes to the infrastructure side as well. So a lot of your cloud and hybrid cloud, strategies and kind of your best practices around that. And I think you guys are familiar with Ansible as well. So we do a lot of, automation and have those conversations also. And a little bit of the flow for today, like I said, it's a smaller group, so we want to kind of keep it interactive and kind of keep it pretty low key for the most part. So just kind of, kind of have the flow, and we can just kind of take the slides and kind of move along. But we're definitely going to give you a good overview of what Red Hat OpenShift is. A little bit the difference between OpenShift and Kubernetes, because I know there's kind of been some questions, and maybe some people kind of like the do it yourself version versus OpenShift, and kind of give you the benefits of why OpenShift, and then kind of backing up a little bit even off of that as well, and kind of going into why containers, why microservices and that kind of architecture, and kind of gearing the conversation that way. And then a little bit of overview of how you will benefit for adopting OpenShift and using it in your environment. So with that, I will leave it to Jared here, who will go into our conversation and going into the slides here of what is OpenShift. Thank you.
Thanks for the introduction, Aaron. Again, my name is Jared, and let's dig in here. So what is Red Hat OpenShift? I'll read the text and then I'll drill in, and I'll kind of keep that as the theme as we go throughout the webinar, just to give that high-level overview with a little bit more context. So Red Hat OpenShift is the leading enterprise Kubernetes platform. It's built for open hybrid cloud strategy. It is full stack. It's built for automated operations, and the purpose is to provide a consistent experience across all environments. And think of that as deployment environments. That could be cloud on-prem, many other types of environments as well. They also have local development environments and variations of OpenShift, like what's called mini-shift. So it's a consistent experience for both developing and deploying code. It has a self-service provisioning model for developers. And the whole purpose of that is to provide greater efficiency from development to production. OpenShift has really come a long way since its original inception to where it is in OpenShift 4 now, where the emphasis really is getting you a stable deployment with lots of day 1, day 2 type operations. Historically, OpenShift, at least with OpenShift 3, it started off with tons of automation, lots of configuration, and it was sort of difficult to deploy initially. And a lot of those improvements have been made over the years as the solution has matured. And when we ask what is OpenShift really is underneath it's Kubernetes, but it provides really all the additional capability needed to make it a true enterprise solution that's ready for large enterprises and teams to consume out of the box. It's basically, OpenShift is to Kubernetes what Red Hat Enterprise Linux is to Fedora. And it provides tons of capabilities beyond just what your vanilla Kubernetes would provide between the self-service, multi-language, automation and collaboration piece. OpenShift provides lots of capability that enterprises need, predominantly authentication. That's like OAuth type authentication, centralization of LDAP and user sync, and all the different types of enterprise capabilities that you would expect from, again, a robust enterprise solution that you're really building your entire software practice around. Next slide. What challenges does Red Hat OpenShift solve? At a high level, it helps application developers build with greater speed and agility. And choice is also a part of it, because OpenShift is basically just containers. That allows it to deploy really any containerized workload, but it does that in a consistent, secure way. It increases efficiency with automated operations, but that automation doesn't sacrifice stability. And I think another key point there is that it doesn't sacrifice stability, and it also doesn't sacrifice scope. A lot of times when you introduce automation, it honestly is a lot easier to just build a snowflake and just have this really robust instance of the thing that you need out there. So say that's your automation tooling or your deployment tooling. It's generally easier to just build that once and sort of maintain it. But obviously you lose a ton of the benefit that you get from automation, which is the ability to rebuild it if you lose it. And really the ability to rebuild it if you need a second one, right? Maybe another team needs to scale up, or you need to scale up infrastructure in general. OpenShift is built with all this automation inside of it to enable teams to then be able to scale up fast without sacrificing the level of automation that it's got built into the platform. And it also empowers businesses to transform, and it really does unite teams across a single platform. I've been in organizations where we've attempted to do something like OpenShift, and this was very early on when containers were really starting. And if we would have just had OpenShift at the time, we would have saved ourselves exponential amounts of time and money. And I don't say that lightly, and I don't say that just as marketing jargon. It truly is a time and effort differentiator. It allows you to accelerate the adoption of containerized workloads from all the way from deployment to production, with the security built in, with really all the best practices of how to do that built in. And it is built on really the de facto container orchestration platform, which is Kubernetes, which continues to grow and scale and be adopted. Next slide. So this is a look at the way that the architecture of OpenShift is. And you can see at the bottom box here, we've got the container host operating system. Today, the preferred operating system is Red Hat Enterprise Linux CoreOS. That was after the Red Hat CoreOS acquisition. And if you're not fully aware of what CoreOS is, CoreOS was a container-specific operating system, and it uses a immutable file system. By that, instead of having a file system that's traditional, like you have your Windows machine and you get Windows updates on a regular basis. And then if you were to lose that operating system, there's really no known state, right? It could have had some updates, it could have had all the updates, it could have had none of the updates, but that makes it incredibly difficult when it comes to understanding the dependency chain that was associated with that machine, understanding the security patching and everything else that was done. CoreOS eliminates that by using immutable file systems, where it's almost like it's like a snapshot of a file system at a given point in time, and that creates tons of stability, and it also makes updating very simple. And Red Hat CoreOS is basically a hands-off operating system. You really don't touch it. When you run automated upgrades inside of OpenShift 4, if you're deployed using what's called an installer provision infrastructure pattern, it will actually manage the infrastructure, whether or not that's in VMware, or if that's OpenStack-like environment, or if that's in the cloud on Azure or GCP or AWS. It can actually manage the machines, and it will manage the patching of those CoreOS operating systems. If needed, you can run a traditional Red Hat Enterprise Linux on just the worker nodes, but it is required for the masters to use CoreOS. And the features that come with CoreOS, the lightweight nature of the operating system, and really just the fact that you get a dedicated container operating system really does make it the preferred choice. On top of the host operating system, you've got the Kubernetes orchestration, along with the Kubernetes cluster services, and that really covers the OpenShift Kubernetes engine. So this is Red Hat's, think of it as the fortified version of the Kubernetes engine, and that contains everything like the installs, the over-the-air updates, networking, ingress for traffic outside the cluster to get access to applications inside the cluster. That covers storage, monitoring, logging, the container registry where all of your container images live that get deployed for Azure applications, authorization, the containers themselves, not just the registry, but the literal running containers, virtual machines using something like KubeVirt. So Red Hat does have the ability, OpenShift does have the ability to deploy VM-like containers. And then you have operators, which really are the future of OpenShift. And if you think of an operator, what an operator does is it's a piece of software that lives inside the OpenShift cluster, and it manages the life cycle of a particular application or service. So think of it like a database, and in that database you have schema, or you have updates to the actual database version itself. The operator is responsible for maintaining the life cycle. So it can do things like automatic backups and take your backups and push them into bucket storage. And it can retrieve backups. It could do schema migrations to keep your schema definitions up to date. It could do version patching. And that piece of software lives there, and it takes the burden of those updates off of an actual operations engineer so that they can put more emphasis on other things. And what OpenShift is moving towards is really a pattern that frees up engineers to not have to do the mundane. And a lot of times that can be a hit to a lot of those engineers, because they say, well, what exactly is it that I'm going to do? And the reality of it is engineers always have things to do. We have tons and tons and tons of things to do. And now those engineers are freed up to begin automating other processes. And when we talk in terms of automation, I know that's sort of a sidebar, but when we talk of automation, I think it's important to note that really the purpose of that automation is to reduce errors, to maintain consistency, and also to take that tribal knowledge out of the head of that engineer and put it into a finite piece of source that's intelligible. It's basically a coded pattern, and that benefit really can't be undermined, because now if that engineer has to move departments, move up or down departments, they go and they get a new opportunity somewhere, you haven't just lost the ability to have that operation running. And operators take it the next step by then taking those processes and putting them inside the cluster. So it's like living automation. It really is a really, really interesting concept. And OpenShift 4 is built with these living automated operators. And then the final piece in that Kubernetes cluster services is the Helm charts. And if you don't know what Helm is basically sort of like it's like a Kubernetes application package manager, and it allows you to templatize your application deployments, and you use Helm as a tool to then say, hey, Helm, I want this application deployed, and it needs all these different Kubernetes resources. So that could be ingress route to allow traffic to access a web app, or storage, or secrets, like, it could be database secrets or API token secrets, secrets that it needs itself, secrets it needs to other applications. And what Helm allows you to do is take all these disconnected Kubernetes resources that have to be created. It allows you to templatize them, inject in template values or parameters whenever you go to deploy that service, and then and it allows you to keep it all centralized in one place and maintain it. And the beauty of Helm is that you can use that in your deployment on the tail end of your application delivery process. And now you have a consistent way of deploying that application every single time. And then on the top of this stack here, we've got the actual OpenShift container platform. And it's got the platform services. So you've got things like service mesh, the builds and CI/CD pipelines. There's now an actual pipeline capability built right into OpenShift that uses the newer industry standard tools. Argo CD is one of the big tools that they're using. And there's also Tekton, which is coming as well, which is really, really powerful. Tekton is like more like a cloud native, Kubernetes native way of doing CI/CD. That's a differentiator from your sort of traditional tools for CI/CD like Jenkins and other tools. It's got log management, cost management, and you have your own application services stack. So that's the different languages, your APIs, integrations, messaging, process automation. And then you have data services. So you can run databases, you can ingest data, you can do data in ML. And then obviously you have the actual services that are provided for developer productivity, which is the developer CLI. So there's an OC client that, in addition to the web interface, you can go into a web interface and manage OpenShift. You can also use a CLI to do things if you have power users, or if you want to automate processes in the OpenShift cluster itself, you can use the CLI for that purpose. It is pluggable and extendable, and the main way you extend it is using operators, which is awesome. So say you have some process that you're doing on a regular basis, like for instance, managing certificates, and you have a certificate authority, and that certificate authority is registering and sending out different intermediary certificates to your applications. You could create an operator that would sit inside of your OpenShift cluster that could have your own unique business logic for how you guys manage your CA certificates built into it. And now you can extend OpenShift and have OpenShift be the platform where you're able to deploy that capability instead of figuring out, well, do we put it on some server, or do we put it here, or do we put it there? It can now become a native part of your actual OpenShift cluster. But there's also code-ready workspaces, which are super cool. Code-ready workspaces is through Red Hat's acquisition of a company called CodeEnvy a while back. And what code-ready workspaces are is they use technology called Eclipse Che, and behind the scenes, they actually have a cloud-based workspace, and that workspace has like all of you basically can access it from anywhere, and it's got tons of projects and resources and other things integrated into it. And it can actually allow teams to simultaneously code in the same environment. So if you have a pair programming situation where you need another developer to come and assist in that process and you're working remote, it's really, really beneficial. There's no screen sharing needed. You're literally sharing an IDE. So super powerful stuff that's provided by OpenShift, and tons of it is provided by the underlying Kubernetes, but Red Hat just goes a step farther with OpenShift and just really blows the capability out of the water as in comparison to really any other solution on the market. Next slide. Red Hat OpenShift and Kubernetes. So I'll read this first, like I said, and then I'll kind of elaborate. So Red Hat OpenShift is a certified Kubernetes platform and distribution, not just Kubernetes. So there are certified Kubernetes distributions out there as well. Red Hat is, I would argue, the most robust one there is. There's also like the certified canonical, which is Ubuntu, the canonical distribution of Kubernetes. There's other solutions out there as well that are certified Kubernetes platforms. Red Hat's biggest differentiator is, number one, Red Hat was contributing to Kubernetes extremely early on. And Red Hat brought OpenShift to market, and at a time where Kubernetes hadn't quite won. There was still, oh my goodness, I just forgot the name. Here, I go to one I knew though. There was Docker Swarm was on the market, and Docker was attempting to do this whole orchestration process. And then there was also what is called DCOS today, and I think it started as not WebSphere. I cannot Mesos and Mesosphere. That's what it was. So there were really three big players. There was Mesos, Swarm, and Kubernetes. And at the time, those orchestration platforms were all competing, really vying for the market share of orchestration. And when we talk about orchestration, if that concept is still not concrete, you have Docker, or at least you started with Docker. Nowadays, there's a complete container runtime interface, which is a separate thing. But you had Docker in the beginning. And Docker allowed you to do the container runtime, but it was only on one machine. And obviously that doesn't scale. So that's really where container orchestration came about. And that's really what brought about Kubernetes. Is it was allowing you to take Docker and spread it out across multiple machines and basically scale it horizontally. And that had to cover a lot. It had to cover security. Obviously you had node-to-node encryption via TLS. So everything had to be encrypted. You had to have the ability to manage the network between the nodes. You had to have the ability to manage storage between the nodes, which is one of the biggest ones. And that's really where Kubernetes got its rise. Red Hat really standardized on Kubernetes early on while there was still this container orchestration war. And that's one of the benefits of Red Hat and OpenShift, is that they were on Kubernetes very early on, and they have been with Kubernetes very early on. And there's this beautiful parity between the two, where you really can feel this sort of Kubernetes native experience. The disadvantage of a lot of the existing certified Kubernetes platforms on the market is that one, they're just not as robust as OpenShift, and two, OpenShift really brings the user interface game. Some people care about that, some don't, but I'd argue that even as a power user, sometimes nothing beats a user interface. And OpenShift's user interface is bar none the best in the industry. It's just, I've never seen anything else like it that competes when it comes to Kubernetes dashboards. Even literally GKE itself doesn't hold a candle to OpenShift. OpenShift they've completely won the user interface game as far as I'm concerned. And it's not just the user interface that like makes you feel good and it's like, wow, this looks nice and it's all form over function. There's a ton of functionality built in. You get log feedback. You can go in and look at all the different states of the containers. You can manage all your administrator resources. You can get details about your Istio container mesh magic and all the stuff that's going on there. There's an admin interface. There's a developer interface. There's a ton built into it. And that's one thing you're going to get with OpenShift that you don't get with a lot of other distributions. And also Red Hat OpenShift is the leading enterprise Kubernetes platform, which is sort of what I've been alluding to. And it allows organizations to run really straight to production. So that's your Linux platform, your storage, networking, logging, everything is built in. OpenShift is built to run enterprise workloads day zero. That's really the way it works. And that's all the way from, like I said, logging. You've got monitoring, you've got Prometheus, you've got Alert Manager to get real-time alerting and everything else. And it's also extendable or extensible so that you can add on and plug in whichever additional enterprise features are needed. So as far as getting the ball rolling, OpenShift is going to get you way farther than most other solutions. I would argue way farther than any other solution on the market. These are just a few more points. It's everything you need out of the box. It is fully integrated and automated. And when we say fully automated, the installer is really beautiful. OpenShift 3 was beautiful-ish, but when we compare it to OpenShift 4, there really just is no comparison. OpenShift 3, you had a ton of, like I said, it was this massive file you had to create, and there was all this configuration. You'd hit the installer, and it would go and it would run. And for the most part, it was, once you got it working, it was really, really good. OpenShift 4, you create what's called an install config, and you run this installer, and it just goes off. You just sit and wait, and about 30 minutes later, you've got yourself a cluster. Can be less, can be more, it just depends on what all you're running. And the reason why OpenShift 4 is so good is because again, they focus on reliability in that day zero installation. They don't try to do all the custom configuration and everything yet. They put the emphasis on, let's get you what's called the control plane, which is your 3 masters, and let's get you a handful of worker nodes so that you can deploy workload. And then they have extreme levels of documentation for all of your day 1, day 2 operations. So that's, going in and adding more workers, creating different machine pools, doing additional configuration inside of those machines if you need certain packages or CA certificates and all that different stuff. You've got your backup capability built in, and all this stuff is extremely well documented to make sure that you can hit the ground running with the solution right out of the box. And it is a one-click platform. It does have one-click platform and application updates. The application update part of OpenShift 4 is really, really cool. What it is it basically is a giant graph, and obviously I don't mean a visual graph. I'm talking like a graph data structure, and the updates are all joined together by this concept of nodes and edges, which is the pretty standard graph data structure. And if you think of every update is a node. And what Red Hat does is they collect telemetry data, so that way they're getting feedback about all these updates and other things and errors that are occurring in the system, so that can clue in whether or not updates are actually effective. And they connect all these edges. So think of an edge as basically this update leads to this next update, what goes to this next update. So say you want to go from version 4 to version 4.6. There may be a number of updates that occur between that entire process, but that is a finite mapping, and it's all pulled together based on feedback from all these other clusters that are cluing in the update manager as to, should I move forward with this update or should I not? So it's very sophisticated, and it's really awesome that in a sense you're almost participating in this community effort to make the entire solution better and better. And you have these stable update channels. You literally go to the update you want, you click the update button, and the entire cluster goes and deploys what are called the cluster operators, which control really all of the internal cluster functions. And you'll go through that series of updates to go from point A to Z, and there could be a number of updates in between. But at the end of the day, they are click button. There's none of this crazy patching and everything else. And there are thousands of customers running production workloads across FSI, telco, energy, retail, government, and other sectors, and there's so many customers using OpenShift. I've personally used it when I was at Cisco, and I'm currently using it in some environments and things today as well. So, why containers? So going back, as Aaron said, back to the container conversation, sort of stepping away from OpenShift specifically right now. If we talk about why we want to deploy containers, because sometimes it is important just to get back to the basics of, okay, that's great. OpenShift allows me to deploy containers. Why would I transition away from my existing way of doing things and move to something like OpenShift? Because the reality of it is as amazing as OpenShift is, there is still a transition that has to occur to begin to adopt technology like OpenShift. Predominantly, this whole concept of cloud native deployment. If you've heard the term 12-factor apps, that's also extremely important terminology that you need to understand when it comes to moving into building containers. And it really comes down to things like using environment variables, proper versioning of your code, the way that you're automating your code and builds, and really all of those different elements come into play when it comes to building containers. So why go through all that effort? Like, what is the benefit? The number one benefit, I would argue, is that, well, I won't say number one, but very high benefit is faster deployments. Your deployments are going to be exponentially faster using containers than they will pretty much anything else. Why? Well, because containers, they're just another abstraction, right? We have physical machines, and then we transition to virtual machines, because virtual machines were an abstraction on top of the physical. And in effect, the physical machine became a runtime for the virtual. And now you have that next step where we're creating an application abstraction, right? Where the virtual machine was an actual compute abstraction. We've now, with Docker, created an application abstraction, and it allows tons and tons of consistency, dependency isolation, and really all the benefits you get going to something like virtual machines, you now have at the application level. And because you're just depending on a container compliant application runtime being on the environment that you're deploying into. As long as you have a container image, you just throw that thing in that environment and it just runs. So deploying is really fast. And along with faster deployments, actually, I'll hold this point until we get to high production and portability, because I think it plays into those as well. You've also got this concept of the service mesh. In OpenShift terminology, it's called Istio. And this tool allows you to do really, really interesting things. So the service mesh handles more complex ingress and egress of traffic in and out of your applications and inside of the cluster. Main thing that Istio is going to give you is egress control, so you can actually control outbound traffic. Out of the box, you can control inbound traffic pretty well with OpenShift using a concept called network policies. And network policies allow you to restrict access within each project. So if you think of project, it's like basically a namespace, or it is a namespace in Kubernetes, but it's called a project in OpenShift. And it basically gives you resource isolation. And it's beneficial because it gives you enhanced security around those resources in that project, and it also gives you enhanced access control around which obviously that's security access control as in users, but it's also network access control through network policies. But the service mesh goes a completely separate level and provides better egress control. One of the biggest benefits that it provides out of the box as well is it provides something called mutual TLS. And mutual TLS allows all of your container traffic inside of the cluster to be inherently encrypted without the need for you to have to manage deploying TLS certificates between services. What it does what's called the sidecar, where you basically have two containers and they run together. And the service mesh will deploy this network controller container, and now your application container will send all of its traffic outbound out of the service mesh container. And that service mesh container will have its own internal CA where it will encrypt that traffic and ensure that traffic from application to application within the cluster is using TLS. And that's super powerful because managing TLS can be a pain in the neck, especially managing certificate rotation and everything else. The service mesh does all that for you. And it's really, really powerful because now, when you're dealing in a multi-node environment, generally you're going to be inside of a cloud, right? Or you're going to be inside of a local data center, and you don't want to get put into a situation where you have a man-in-the-middle attack. That's kind of rare in those environments, but it gives you that extra bit of protection that that even if there was a man in the middle somehow inside of your cloud or inside of your data center, somebody managed to get access to your nodes, maybe you had a malicious internal worker, because a lot of times there are inside attacks, you still have encryption end to end to make sure that any man in the middle cannot actually view the data, right? And that's really, really beneficial. We also have enhanced security. We just talked a little bit about the enhanced security. You're going to get enhanced security from containers because, again, this isolated runtime, it really keeps resources away from each other. And it even goes a step farther in something like OpenShift, because with OpenShift, you can't run containers as root by default. So you don't have this breaking out of the container scenario where someone now gains root access to the host system. And containers really allow you to control the security because there are certain security controls where you can set security options. Obviously, containers, at least in the world of Docker and what CRI-O, which is what OpenShift uses, they allow you to maintain your SE Linux compatibility, and they also allow you to do additional security options to control which parts of the system. Like, say you have a VPN sidecar and you need to give it tunneling capability to talk to a tunnel device on the host. That's something that you can give finite control just to that container for. So it allows you to be way more granular with your security. High production really plays into faster deployment because they're containers. Again, the container has a file, and that file is basically the definition of everything that goes inside of that container. So if you're deploying on a containerized environment, you don't have to deal with system local dependencies. Now your quote unquote system local, right, is now the container, and it gives you full isolation of dependencies. And it also gives you a deterministic environment, meaning there is no pre-existing state. When that container runs, the only pre-existing state would be what was built into the container. So a lot of times, pre-existing state can cause lots of headaches That could be pre-existing directories, pre-existing environment variables, and any other things. That the idea that you're always getting a clean slate when that container comes to life can increase high production. And the one thing, I can't even remember the thing I was going to say from faster deployment that I deferred. So if I remember it in portability, I'll try to get back to it. But we'll go to portability. Portability is the same type of concept that you're getting with something like OpenShift, right? Is that, OpenShift says, hey, give me some VMs and I'm going to deploy all these application capability across those VMs. And that application capability deployed on those individual nodes is collectively called OpenShift, right? It's just a bunch of software that communicates together. You're going to get that same type of portability with containers. And if you think of a container runtime as your JVM, like a Java virtual machine, that was one of the big promises with the JVM in the beginning was, hey, you just put the JVM on the host, and now it can read Java bytecode and execute the application. Anywhere you have a Docker or CRI, which is container runtime interface, as long as you have Docker or a CRI compatible container runtime, you can run the container. And it's I would even go so far as to say the portability is even more granular than that, because you're not limited by the operating system on the machine. You can put whatever OS you want. You can say, hey, I want to run Fedora, I want to run Ubuntu, I want to run Alpine, really any Linux operating system, right? But you get that flexibility. If I want to get a little bit of Ubuntu action on my real machine, I'm not limited to only what the virtual machine provides. I can use different types of base images. So the portability is unparalleled. And scalability. This really is the big guy when we talk about large enterprise capability. Containers just scale. They scale so easily, and that's where OpenShift really comes into play when we talk about containers, because we're not talking about vertical scaling. We can horizontally scale. And in OpenShift, if I have an app and let's say I have peak times, and all of a sudden we start getting tons and tons of traffic, I can just go on OpenShift in the interface and click an up arrow and just start bringing up more instances of my application. So as long as my development team understands, hey, when you go and you build your applications, you need to make these things stateless. They need to store session state outside of the application. They need to store data state outside of in a database. Well, now if that application is stateless, then it can scale infinitely because it's connected to all these external systems. And I can bring up 100 of them when, all of a sudden it's 5 o'clock and everybody wants to watch cat videos or whatever, right? Whatever the need be. And OpenShift, just kind of bringing in an OpenShift note here, it takes things to another level. It's actually really cool the way that it manages the scaling of pods. Is you can do what are called horizontal pod autoscalers, where you can scale pods automatically based on a given load to a particular pod. So if that pod CPU reaches a certain amount, OpenShift will say, hey, I need you to bring up another pod. Now, if that pod reaches a certain amount of CPU and you're doing things the way you should be setting limits on the resources of that particular application. And if that application reaches a threshold and now all of a sudden it exhausts the resources across the cluster, well, the cluster is going to say, I would love to scale another one, but unfortunately, I'm out. I don't have any more compute to work with. But with OpenShift on installer provision infrastructure with what are called machine sets, you can actually make it where you can do infrastructure scaling. So now an entirely new virtual machine will be brought up, and now workload will be balanced across that virtual machine. And it can automatically be reduced based on a reduction in usage. So for your peak times, you can dynamically scale your system, and then it can come right back down, which is just, it's pretty insane. That's really, really unparalleled. Last slide here, how customers benefit. You get increased production and effectiveness of development teams, which is really, really good. You not only get the increase, but you also get the visibility. You'll get the flexibility and the scalability, and it allows you to deliver innovation at speed and scale of business and customer demands, which really that's the bread and butter, right? We want more emphasis on business development, less emphasis on technical development, right? We don't want to spend our time building technical systems. We really want to change the world with the solutions that we're delivering, and OpenShift is going to allow you to do less technical work and more business work, and that really is the big benefit. Aaron, you were going to pick this up here, right?
Yeah. Yeah. Thanks, Jared. And I guess the only other thing that I'll kind of add, to that as far as how customers benefit, it's nice having the unified platform, that's allowing you to produce so much more, right? And creating more efficiency. But even taking a step back from that is, we definitely don't want to underestimate the culture side of this, and I know Jared could, speak, to that as well, but it's like, enabling you to adopt things like DevOps and not only, you increasing, your application, life cycles and able to, speed up development, increase, operation efficiency. Not only is, OpenShift doing that for you from a technology standpoint, but it's also allowing you to, increase collaboration and teamwork within your organization. And that's just, in our opinion, just something you can't really put a dollar amount on, right? It's just, just a huge benefit. And then going to that, just the last slide, we just wanted to throw out just a few, percentages and stats as well, just of what organizations just as an average are seeing just across, kind of going back to some of the customers that we're seeing just through retail and in the government sector, also in a lot of financial services companies are using OpenShift and are seeing these types of results, and even a lot, like I think you guys may have some experience with Ansible and kind of going back to some of those benefits as well, of seeing more of that immediate, ROI, that you're able to kind of see those results and that return on investment sooner than later. So that's always a big benefit. So I don't know, Jared, if you have anything to that, but if not, not sure if you guys have any questions. That kind of, wraps up the presentation. Jared, I appreciate your, giving the dive on your side. Not sure if you guys have any questions, comments. Feel free to ask anything, unmute yourself, any feedback, anything you have. I think someone was trying to talk there. Someone lit up. I didn't know if no worries. If I don't know if you're muted or not, but go ahead.
Yeah, it looks like it's lighting, but I don't hear it either, Aaron.
Okay, no worries. If you have it, you can put it in the chat too, if anyone's having any kind of issues also. But Jamie, I don't know if you have anything or if anybody else has any questions. We appreciate your time.
No, I think that's all we had.
Awesome. Well, we appreciate your time, everyone. If you have any, additional questions or comments, you can feel free to reach out to Jamie, or, anyone within our team as well as DLT. Appreciate it. Thanks.
Thank you for everyone joining today. We hope you found today's webinar informative and meaningful. As I mentioned earlier, this webinar was recorded and we will be able to download on the DLT Marketplace so you can share with your colleagues or watch again on demand. Enjoy the rest of your day and thank you again for joining.